Questions to questions to test one on general physics and vectors. So we're doing question paper B, which says that the gravitational field stranded at a point within the this gravitational field depends on the gravitational constant G. The gravitational field strength depends on the gravitational constant G, mass m of the Earth, radius r from the center of the Earth. Find an equation linking G, m, and r. So I told that G is equals to force per unit mass, which is kg meter per second squared over kg. So the units for G is meter per second squared. So this reduces to meter per second squared is equals to k. We're told that the units for G, universal constant of gravitation, to the power x, m is mass, which is kg, to the power y, and r is distance, which is m to the power z. So this becomes ms, which is kg to the power minus x, m to the power 3x, s to the power minus 2x, kg to the power y, m to the power z. Right. So this will become m minus x plus y. So this will be kg minus x plus y, which is m 3x plus z, which is s to the power minus 2x. Right. So I'm going to continue, because we have to find the equation linking G, gravitational field strength, and G, which is gravitational constant, m, mass of the Earth, and r, distance r from the center of the Earth. So we'll have ms is equal to kg y minus x, m 3x plus z, s to the power minus 2x, which is 1 is equals to 3x plus z, minus 2 is equals to minus 2x, then there's no kg on the left hand side, so we have 0 is equals to y minus x. So x will be equal to 1, and this will be 0 is equals to y minus 1, therefore y is going to be equal to 1, and this 1 will be equal to 3 times 1 plus z, so z is going to be equal to minus 2, right? So our equation earlier on we said G is equals to k, G to the power x, m to the power y, r to the power z, which is, this becomes G is equals to k, x is what? We said x is 1, then we said y is 1, and then we said r is minus 2. So the equation linking G, m, and r will be G is equals to k m over r squared. This is the equation linking G, m, and r. That is the answer. So you are applying the homogeneity of physical equations to teach the relationship between G, m, and r. So we'll move on to question 4. Question 4 says, define the term homogeneous equation. Question 4a. homogeneous equation is defined as an equation in which the terms on the left hand side have the same base units as the terms on the right hand side. That is the definition of homogeneous equation. Then I'm going to move on to 4b. So how to solve 4b? Show that the following equations are homogeneous. So we'll quickly go through 4b part 1. 4b part 1. So the equation is V is equal to minus Gm over R, where M is the mass, G is the gravitational constant, R is the radius. V is work done over mass. Work done over mass. Then G there is per kg meter cubed per second squared, and M there is kg and R there is M. So this is the right hand side. So on the right hand side, kg times kg is this reduces to meter squared per second squared. This is what is on the right hand side. So we should also show what is the base units on the left hand side. So work done on the left hand side is kg meter per second squared times meter over mass is kg. So this cancels. M times M is M squared. M squared per second squared. So this is the left hand side. This is the right hand side. So the base units on the left hand side are the same as the base units on the right hand side. Therefore this equation is homogeneous. So we're going to move on to 4b part 2. 4b by 2. Show whether this equation is homogeneous. E is electric field strength, which is Q over 4 pi epsilon naught R squared. E is force over charge, which is force is kg meter per second squared over charge is ampere second. So this should be kg meter per second cubed. Kg meter per second cubed per ampere. So these are the best units for electric field strength. So the electric field strength is on the left hand side. Then on the right hand side, charge is ampere second. Then epsilon naught, we are told that the best units for epsilon naught are per kg raised to the power 4 A squared m to the power minus 3. Then for R is m squared. Right. So if you calculate very well, the A over A squared is A to the power minus 1. 1 over K per kg is going to be kg. 1 minus 4 there is S to the power minus 3. Right? Minus 3 plus 1 there will be minus 1. So it will be M. 1 over M minus 1 is M. So the best units on the right hand side are the ampere kg per second squared per M. The on the left hand side is kg meter per second cubed. So these best units are the same. Therefore this equation is homogeneous. Then we'll move on to 4b part 3. 4b part 3. 4b part 3. Tan theta is equal to v squared over r g. Tan theta is a ratio, so this is dimensionless. So this has no dimensions. Tan theta is a ratio, so it has no dimensions. So V is meter per second squared there, over R is meter, then G is meter per second squared. Because G is acceleration of free fall, R is directions. So if we calculate very well, they will get meter squared per second squared over meter squared per second squared, which is also going to be 1. So the left hand side, the right hand side has no dimensions, and the left hand side has no dimensions. Therefore, tan theta, this equation is homogeneous. So moving on to question 5. We've got this equation for question 5. Q is equals to Q naught exponent minus T over RC. So I want to calculate base units for C. So for an exponential equation, this is dimensionless because exponent is to the power of a constant. So T over RC is equals to 1. So C is going to be T over R. Right? So T, this will be second. So now I left with base units for resistance. Left with base units for resistance. R is resistance. So R is voltage over current. Voltage is work done over charge. So it is times 1 over current. So this will be kg meter squared per second squared over ampere.